Okay, so one of the issues that will invariably come up with critical path method is how to perform a forward and backward pass. So I wanted to give you an example out of the textbook. This may also be a question that you might see on the test. I would go through chapter 4 quite thoroughly. This is about as fundamental skill as we get with scheduling, so it is important that you pay attention. So the question is as follows: diagram the following activities using activity on the node and identify the critical path with a separate colored pencil. So right here I have blue and red pens, and I'm just going to diagram this out. So again, if you want to follow along with this example, it's example 4.2 in chapter 4. The sequence of activities is laid out as follows. A starts things off. There's no immediately preceding activity. It's a 2-day duration. The durations are actually new this week. Last week you should have done basic networks with no duration for time, so this is the difference. So A is followed by B, C, and D. These are 6, 10, and 4-day durations respectively. After B comes E. I think everybody understands how to link these up logically right now. I won't go through the rest of what's linked to what. That is crucial in your ability to calculate the critical path, but by now you should be able to do that. So I'm just going to start out with A, activity A right here. I'm using activity on the node. See, my pen won't work. There we go. So activity A, I'm going to put the letter right in the middle, and I'm going to put the duration right below it. In this case, it's a 2-day duration, so I put that right there. A is followed by 3 activities, so I do want to be able to lay these out correctly, and it's easier to do a bunch of examples so that on the test you're accustomed, or you've at least practiced how to lay out the logic diagrams. The other things I would suggest to you here is that you leave yourself enough space above and below the nodes to be able to place the date. So you see where this space right here, where these two nodes are close together, there'll be 2 dates here on the bottom of this square and 2 dates on the top of that one. So the spacing between these squares is important too. So I'm going to put B here at 6 days, C here at 10 days, D here at 4 days. And these are linked to A like so. Finish to start relationship. We're not doing anything particularly fancy yet. So A is the predecessor of B, C, and D, and they're all linked together that way. Can't have E over here, and activity E has B as an immediately preceding activity. The duration is 7 for this activity right here. So I'm just going to draw an arrow like that. F has both B and C. This might look a little different than the version in the book, and I do have sort of a space problem here already, so let's hope that I can make this work. And also on the test, when you get a similar problem, just keep in mind that you're going to have similar space constraints. You're not going to be trying to do a video online, so maybe that's part of the issue right here. I'm trying to make this visible and all that at the same time. So F has both B and C as a predecessor. I got to link those together like that. G, I would come down here with G. G has a 3-day duration, and it has C and D as predecessor. So I link C and D. Notice I'm linking these things from the finish of the activity to the start of the other one. Okay, and as for right now, we're not doing anything fancy, so those need to be linked at the start and the finish of the activity. So activity H has both E and F. I'm going to put that over here. H is a 5-day duration, so I put that number here, and I link E and F to it. I has G and H linked to it, so I need to put another activity over here, activity I. It's a 2-day duration, and its predecessors are both G and H. So G and H. And actually, if you're doing activity on the node, you would stop right there. The forward pass works as follows. In each and every one of these squares right here, you're going to have a random activity. It's going to have a number or day duration here. And if you look at the textbook, the convention here is the early start date goes here, the early finish date goes here, late start goes here, and the late finish goes here. So let's see if we can work our way through a forward pass, maybe understand some of the logic. I apologize that this thing's kind of going in and out. It has an autofocus. So please bear with me. I'm hoping that y'all can see this pretty well. If not, please follow along in the book and you should be able to make sense of what I'm doing here. So if I want to start out with a forward pass on activity A, I would go first of all and figure out what is the earliest day I could start out with activity A. Just about every single activity that you start out with in these diagrams is going to start on day 0. That's our convention, at least. The way I do the forward pass is I'm going to do the dates along the top first. On the backward pass, I do the dates along the bottom. So I'm doing basically early start and early finish for each of these dates right here. Early start for activity A is 0. It's a 2-day duration, which means that the earliest I could finish activity A is 2 days later. So early start 0, you add the duration of the activity, early finish would be 2 days. Now this will start making more sense when we start doing B, C, and D. Activity B, when is the soonest activity B can start? Well, it depends on the predecessor, right? So if I go back here and look at this predecessor, I will take this 2 right here and transfer it to the early start of B. So this is the earliest I can finish A is 2. That means that the earliest I could start B is 2. 2 plus 6 day duration, the earliest I could finish B would be day 8. Okay, I'll do the same thing for activity C. It depends very much on the predecessor. So the preceding activity, the earliest I can finish it is day 2. I take that 2 over here. The earliest I could finish activity C is that day 2 start time plus the duration. So that would be day 12. Same thing for activity D here. I transfer the 2 over there. That's still the same logical relationship. They're all linked to activity A. So that's 2 right there. I take the 2 plus the 4-day duration. That gives me 6 right there. How soon could I start activity A? So what are the immediately preceding activities for activity E? It's just B. So I take that 8 and place it over on top of that E right there. I apologize if I'm spinning off into the table here. I don't think it affects things too badly, but this will be the only one anyways. I take that 8-day start time, add the 7. The earliest I could finish activity E is day 15. F has 2 predecessors, okay? It has both B and C. So here I have a predicament. I have to pick either the 8 or the 12. And going through the forward pass, I take the latter of the 2 dates, okay? So if I'm confronted with 2 choices here, I have to take the 12, not the 8, okay? So two predecessors, I've got a choice between 8 and 12. Going forward, I pick the latter of the 2 dates. So I bring that 12 over here. 12, add the 5-day duration. The earliest I can finish that is day 17. Same thing with G. G has 2 predecessors. Okay, it has both C and D as a predecessor. I'm given the choice between day 6 and day 12. Going forward, I pick the latter of the 2 dates. That 12 transfers over here. 12 plus 3-day duration. This one's going to be 15. H is the same situation. So I have 2 predecessors, both E and F, that are linked to H. I have my choice between an early finish date of day 15 or an early finish date of day 17. Because the start of H is dependent on both of these, I cannot start until the latter of the 2 is finished. In that case, in this case rather, it's day 17. So transfer the 17 over here, add the 5-day duration. That gives me 22 for day H. Same thing for activity I. I've got a choice between 2 predecessors, G and H. G and H. This one's day 15. This is day 22. I'm going to take the 22, the latter of the 2 dates, and transfer it over here. 22 plus a 2-day duration, that gives me 24. So this gives me a pretty good indicator, at least in basic critical path method, of how long the activity is going to take. In precedence networks, as we work our way through the semester, it's going to be a little bit different. But in that, I might have just a critical finish to an activity or something like that. But this is a pretty basic exercise, even though this is one of the maybe the more complicated examples in the book in this chapter. It doesn't have lags, mind you. I will be able to maintain this duration right here. So let's do the backward pass. It works similar, except on this occasion, if I'm confronted with two successors, I pick the earlier date. So what's the latest? I guess the question you need to ask yourself in establishing late finish, late start is, what's the latest I could finish this activity without delaying the whole entire project? Answer is 24. It's basically I carry that number down here. How do I do the backward pass? I subtract the duration now from that one, and that gives me my late start. So the latest I could start this activity without delaying the entire project is the 24 minus the 2. Put 22 right there. Going backward, we'll do H first. So this is still connected to this right here. Instead of transferring the early finish, in a lot of these, I'm going to be transferring the late start to the late finish here. So my question before answering activity H is, what is the latest date I could finish this activity without delaying the rest of the sequence? And the answer is basically right here, that late start date from the successor. So I take this 22, transfer it over here. I got a 22. The latest I can finish activity H is on day 22. The latest I could start activity H is the late finish minus the duration. So this right here is going to be 17. 22 minus 5, 17. Activity G is going to work a little bit differently. You got already an early finish date, and this is going to be the first thing that differentiates a critical activity, what will be a critical activity, from a non-critical activity. So this one right here, it says the late start is date 22. What's the latest this one could finish without delaying the successor? And the answer is right there again. It's the late start date. I carry that 22 over here. Latest that can finish is day 22. If I finish on day 23, for example, then I push activity I out another day. So the latest I can finish activity G is day 22. I subtract the 3-day duration from that 22, and that gives me the late start. So I could theoretically start activity G on day 19, finish it on day 22, and not delay the overall project duration at all. So work our way to F. Again, I need to look at the successor activity. F has but one successor. So I want to look at this late start date again. The question I need to ask myself is, how late can I finish activity F without delaying the rest of these activities right here? Find the answer right here in the late start. I'm going to carry that 17 over this way. I subtract, where did my thing go? I think we're still recording. Okay. Sorry about that. Screen went blank for a second. So I take that 17, the late finish date, subtract my duration. That gives me 12. And from there, I can work my way to E. Okay, so E, I have the choice. Basically, I've just got that one successor again. I'm going to take that, because I asked the same question, basically. How late could I finish activity E without delaying the rest of these activities right here? I find the answer right here in that late start date. So that's, again, 17. I take the 17-day late finish, subtract the duration. That gives me 10. So theoretically, I could start activity A on day 10, finish it on day 17, and not have any impact on the remainder of the schedule. What about activity D? So activity D has but one successor, and it works like this. Basically, I'm going to take that late start date, transfer it over here. So that 19, subtract the 4-day duration, that gives me 15. Theoretically, I could start activity D on day 15, finish it on 19, and it would have no bearing on the completion of these other activities. It wouldn't push out the schedule at all. This one's a little different right here. So activity C is succeeded by both F and G. So I have a choice between this 19-day duration or this 12-day duration. And on the way back, on the backward pass, I have to pick the earlier of these two dates, okay? The reason I picked the earlier of these two dates is that if I pick the latter of the two dates, that pushes this activity out right here. So my choice is between 19 and 12. I'm going to take the earlier of the two dates, which is 12. I'm going to subtract the 10-day duration. That gives me 2. Same thing for activity B. I've got the choice between 10 and 12. Okay. I have to pick the earlier of the two dates. So I'm actually going to transfer that 10 over here. And I'm going to subtract the 6-day duration. That gives me 4 right there. Last activity, I have to pick the earliest of these these 3 dates rather. So 15, 2, or 4. The latest I can finish activity A is day 2, and what that means is if I finish it on day 15 or day 4, I push all of these other activities out a little bit farther. So I pick the earlier of those 3 dates. 2 minus 2-day duration is 0. I can identify the critical path here. I'll show you guys how to do float here. But if my early start and early finish dates match my late start and late finish dates, that's a prime indicator of how to identify my critical path. I will show you the follow-up method here in terms of how I verify that that's actually the case. But with my other colored pencil, I want to go in and highlight the critical path right here. So A is part of the critical path. C is part of the critical path. Both the early start and early finish match the late start, late finish. F is part of the critical path. H is part of the critical path. And I is part of the critical path. So I also have to link these logical links right here and indicate what the critical path is through this network. What does that mean? That means that these activities, I have absolutely zero room for error. If I deviate from the durations on any of these activities, it's basically going to push the project out. If I shorten the critical path, I have the ability to shorten the entire project. If I'm late on any of these activities, I'm not going to hit the project on day 24. What does that mean about these activities that are not critical? What that means is, what we're going to look at next is that these activities have some degree of float in them. And float is maybe another word, another way of saying flexibility. We'll calculate float in a second here, but that right there should be a good demonstration of how you do just a simple forward and backward pass in a logic network.